Okay, these are energy bar charts or bar diagrams as compared to the energy pie charts we've been using. So how these are going to work, and I kind of gave you guys a little bit of a discussion yesterday, 6th period, as you were leaving. So I'm just going to go through this again, and hopefully you'll pick up what you need to pick up to be able to work on this packet. So initially here, this is the initial information. We have zero velocity initial, and we have a certain y height that is non-zero, so greater than 0. Here in the final position, we have a velocity that is greater than 0, but our y height is now 0. So when you look at the bar charts here, notice we have energy kinetic, energy stored of gravitational potential, and energy elastic. Then final, we also have the same thing, those three, but also we have this energy internal. And remember, this energy internal is the internal shaking and jostlings of the actual particles of the items and objects in the system. So in this case, clearly we have a cart and the ground of some kind, or a hill or a ramp, and so the internal particles of all of these objects, both initial and final, have certain motions. And so the final at this point is going to be different from the initial, and so some of the energy we're saying is actually going to be taken by the movement of these particles. So this is going to be we're just making things up because, and I'm sure you're all laughing right now, because that's what we do in physics. We're trying to get a little more quantitative than we got in the pie charts, but we can only get so quantitative without having any mathematical values to any of these velocities or y positions. So at the start here, I'll say that we have gravitational potential because we have a y height above the 0, but we have 0 velocity. So we don't have any energy kinetic. We do have energy stored as gravitational potential, and I'm just going to make up a value and say that we have 3 blocks of energy gravitational stored potential. And so we would just shade that in. And again, this is arbitrary. I'm just saying this just to start with something. So I'm going to say that this much y height is going to give us a certain 3 blocks of gravitational potential energy. Now, we have to look at the final, because down here we see that we have no y height anymore, but we do have a velocity value that's greater than 0. So the logical thing to do would be that you could say that all of the gravitational that we had over here, all 3 blocks, are now in energy kinetic. And so then you could do this and be done. However, if you're saying in this scenario here that we do have friction present, and there is some interaction of the wheels to the ground and the cart itself, then you might say, well, not all of it from the original gravitational potential was able to become energy kinetic. Some of this, you might say, became energy internal. So if that's the case, then we may, depending on how you've defined this, we may have to take away that energy kinetic that we drew on there, and we may have to go maybe only 2 blocks. Maybe only 2 of the 3 blocks we had became energy kinetic, and another block actually became energy internal, meaning again that in the actual system itself, between the ground particles and the particles that make up the cart, the vibrations and movements of those particles that's where some of the energy may still reside. But the total, initial and final, is still going to be 1, 2, 3, and 1, 2, 3 blocks, both before and after. Now the other thing we can say, if we look at if we look at the same scenario, only now we say, hey, what if there's somebody up here that's actually going to give this cart a shove at the start? So this is still initial. This is still what's happening final. But in the meantime, this person here is going to give a push here to the cart. So how do we account for that, or how do we quantify that? Well, again, I'm still going to say that, like we had before, that there's still these 3 blocks worth of gravitational potential due to the height or elevation of the cart. But at the same time, this person here now has contributed some energy to the cart, to the system. And so this little circle here is going to be our either input or output energy. And so again, I'm just going to randomly make up a value. I'm going to say that there was 2 blocks worth, and I'm going to say that that's going into our system. And again, you have to remember that we're just making arbitrary numbers up here, just to show that we can understand that the initial plus the input is going to have to equal our final. So now we start with 3 blocks of energy initially. 2 more have been added in by the push of the person. So now, if we look over here at the final, you might say, like we said last time, that initially we said 2 blocks. 2 blocks would be our energy kinetic at the end. But now we have this additional 2 blocks to deal with. So I'm just going to start with what we had on the last example, and so I'll color that in. We did say that there was friction, and so there might be 1 block of energy internal. But we still have now these 2 blocks to account for. So it depends on, I suppose, on what you're thinking. Maybe it's 1 additional block of kinetic. Maybe we lost 1 more additional block of internal. That could be an option. Or maybe we have 4 blocks of kinetic altogether. And the 4 of kinetic plus the 1 internal would still sum up to the 3 plus the 2 we had here of input. So, bottom line here, the 5 that we have, 3 at the initial, 2 input, has to give us the 5 at the end. So again, we're trying to quantify a little bit more than we did before, and so we're at least using these arbitrary block values to show energy as it's changing and as it's transferring from object to object within a system. And so without having numbers, this is about as quantitative as we can get. So hopefully this makes sense, and then the worksheet that you're going to be working on will be a little easier to manipulate. Again, don't get too hung up on the numbers of blocks and how you decide how many you're going to pick. It's all just random. No 2 people or groups may even have the same answers. But the goal, again, is to understand how what you initially start with and what you end with have to be the same, unless we have some energy flowing into or out of the system. So hope that helps. I'll see you on Thursday.